Hello everyone, welcome to this Nmap tutorial brought to you by Edureka. In this session, we'll explore what Nmap is, its various modes of operation, and some popular alternatives. We'll then move into the hands-on demonstration where we'll start with the installation process and proceed to run different types of scans, apply various scan filters, and much more. But before we begin, make sure to subscribe to our YouTube channel and hit the bell icon for the latest tech content from Edureka. Also visit the Edureka website for various training and certification courses. The link to the website is in the description box below. Let's begin with understanding what Nmap is. Nmap, which stands for Network Mapper, is a free and open source utility used for network discovery and security auditing. It's a tool that's popular among network administrators and security professionals because it helps them gain insight into their network structures and also security. In fact, Nmap is so powerful that it's not only useful for security auditing, but it also helps with tasks like network inventory, managing service upgrades, and monitoring the uptime of hosts and services. Now let's dive into the key uses of Nmap. First, it's widely used for network discovery, which means finding devices and hosts in a network. It also helps in security auditing by identifying vulnerabilities and weaknesses in the network. Administrators use it for things like network inventory, tracking all the devices on their network, and also for managing service upgrade schedules. Nmap is also handy for monitoring host and service uptime, ensuring that critical services are running smoothly. Moving on, let's talk about the features of Nmap. What makes Nmap so effective is that it uses a raw IP packets into unique ways to get valuable information. For example, it can tell you what hosts are available on the network, meaning which devices are actively connected. But it doesn't stop there. It also identifies what services those hosts are offering, including the details like the application name and version. Nmap can even figure out the operating systems and versions running on those devices. Additionally, it helps in detecting the type of firewalls and packet filters in the place. So, Nmap is an extremely versatile tool that provides a wealth of information about the network you're scanning. Another great feature of Nmap is its compatibility. It's not restricted to just one operating system. It works across all major platforms. Official binary packages are available for Linux, Windows, and Mac OS X. So, regardless of what you are using, you can run Nmap and take advantage of its powerful features. It's a truly cross-platform tool. Finally, let's take a look at the Nmap suite. Nmap is not just about the basic command line tool. It comes with several additional tools that make it even more powerful. One of these is 𝐶hnmap, which provides a graphical user interface, making it easier for those who prefer not to use the command line. Then there's 𝐂𝐞𝐿, a flexible tool for data transfer, redirection, and debugging, which is great for network tasks. NDiff is another useful tool in the suite, which helps you compare scan results over time. And finally, nping is used for packet generation and response analysis, allowing you to analyze how your network responds to certain packets. One of the most exciting aspects of Nmap is its variety of scanning techniques, which we call modes of operations. These modes allow Nmap to explore networks in different ways, depending on the requirements of the task or the level of stealth needed. Let's break them down now. First we have the ping sweep. This mode is used for network discovery. Nmap sends ICMP echo requests to check which hosts on the network are alive and reachable. It's like saying, "Hey, are you there?" and waiting for a reply. Next we have the SYN scan, which is also known as the half-open scan. This method sends SYN packets to a host and waits for a response. If the target sends back a SYNAC, it means the port is open. What makes it half-open is the connection isn't fully established, making it faster and less likely to be detected. The next is TCP Connect Scan. The TCP Connect Scan is a simpler and more direct method. It fully establishes a TCP connection with the host. This is useful when you don't have the privileges to perform a SYN scan but can be slow or more detectable. Then we have the idle scan. The idle scan is a stealthy technique that uses another machine as a decoy. This way, it hides your IP address during the scan, making it highly discreet but also more complex. Then we have the RPC scan. This mode specifically targets RPC services on the network. Nmap sends requests to identify which remote procedure call services are running and collects details about them. Next is the Windows scan. The Windows scan is tailored to identify open TCP ports on Windows machines. It uses specific TCP flag combinations to bypass traditional detection mechanisms. Then we have the bounce scan. The bounce scan exploits FTP servers that support proxy FTP connections. It uses the FTP server to scan a network, hiding your IP address in the process. This method is rarely used today but can be effective in certain scenarios. Then is the UDP scan. Unlike TCP scans, the UDP scan is used to discover open UDP ports. Since UDP doesn't require handshake like TCP, this method can be slower but is crucial for detecting services like DNS or SNMP. The next we have is the FIN scan. The FIN scan sends TCP packets with the FIN flag, which typically signals the end of the connection. Many firewalls and systems don't log these packets, making it a stealthy approach to identify open ports. Next comes the null scan. In this mode, no flags are set in the TCP packets. This unconventional technique helps bypass some intrusion detection systems by not following standard protocols. Then we have the Xmas scan. This creatively named scan sets multiple TCP flags simultaneously, reassembling the lights of a Christmas tree. It's designed to probe and identify open ports but is less common today due to its higher detectability. Next comes the ACK scan. The ACK scan doesn't identify open ports directly, but instead checks for the presence of the firewall or filtering rules. It's more of a reconnaissance tool than a direct port scanner. Next is a version detection. Nmap can also perform service version detection, which probes ports to determine the application and version running on them. This is crucial for identifying outdated and vulnerable services. The last we have is the OS detection. With OS detection, Nmap identifies the target's operating system and its version by analyzing details in response packets. This information can guide further scanning and security assessments. With these modes, Nmap offers flexibility for various scenarios, from basic host discovery to stealthy scans and detailed service analysis. Each mode has its strengths and is suited for specific network setups or objectives. While Nmap is a powerful tool for network scanning and security auditing, there are several alternatives that offer unique features and compatibilities. Let's explore some of them. The first we have is Nmap. Nmap is an official graphical user interface for Nmap. It provides an intuitive interface for users who prefer not to work directly with command line tools. Nmap retains all the functionalities of Nmap, making it accessible for both beginners and advanced users. The next comes the Port Spider. Port Spider is a security tool designed to scan network ranges and identify open ports. Its primary goal is to detect vulnerable services across multiple machines simultaneously, making it useful for comprehensive network assessments. The next is the MASCAN. MASCAN is renowned for its high-performance capabilities, allowing it to scan vast number of IP addresses rapidly. It's optimized for asynchronous transmissions, enabling it to scan the entire IPv4 internet in a matter of minutes. However, MASCAN provides less detailed information compared to Nmap, focusing primarily on identifying open ports. The next we have is the Angry IP Scanner. Angry IP Scanner is an open-source, cross-platform network scanner that is simple to use. It pings IP addresses to check if they are active and can resolve host names, determine MAC addresses, and scan ports. Its ease to use makes it a popular choice for quick network assessments. The last we have is the Fing. Fing is a mobile and desktop application that provides network scanning and device discovery. It's user-friendly and offers features like device recognition, network security assessments, and Wi-Fi troubleshooting, making it suitable for both home and professional use. Now that we have covered the theory behind Nmap, it's time to see it in action. In this section, we'll go hands-on with 3 key aspects of using Nmap, that is, installation, running scans, and applying scan filters. We'll start by demonstrating how to install Nmap on different operating systems, including Windows and Linux. The installation process is straightforward, and by the end of the segment, you'll have Nmap ready to use on your systems. First, we'll start by installing Nmap on Windows. Visit the official Nmap website at nmap.org. Then, go to Download section and select the appropriate Windows installer. We'll wait for it to get downloaded. Next, run the installer and follow the prompts to complete the installation. Now, click on I agree, tick all the checkboxes, and click on Next. Choose the destination folder that you prefer. Click on Install. Wait for it to get installed. Click on I agree again. Install. Now click on Next. Finish. Let's minimize this. Now let's again click on Next. For me, I will be unchecking the desktop icons. Click on Next. Finish. So now we have the Nmap installed on our system. Once installed, you can open Command Prompt or PowerShell and type Nmap to verify that it's working. There you go. You can see that it's successfully working. Now let's install Nmap on Linux. Open your terminal first. To install Nmap, type the following command. So now let's type sudo apt-get install Nmap. Hit enter and enter your password. Anyways, it's already pre-installed. After the installation finishes, you can verify it by typing Nmap in the terminal to see the Nmap version and usage instructions. There you go. Next, we'll move on to running scans using Nmap. Here, we'll explore how to perform basic network discovery and more advanced scans to gather detailed information about hosts and services. Before we dive into running Nmap commands, let's understand the key components that make up a scan. Nmap scans are systematic and structured, ensuring you get precise and actionable results. Here's a step-by-step breakdown. First we have is the scan type. Nmap supports various scan types like a SYN scan, UDP scan, or a full connect scan. Each type serves a different purpose and is tailored to specific scenarios. The next we have is the port number. This specifies which port you want to scan. By default, Nmap scans the most common 1000 ports, but you can customize this based on your requirements. Next is the scan timing. This determines how aggressive or stealthy your scan will be. Nmap offers timing templates ranging from very slow and stealthy scans to fast, aggressive ones. The next is the output types. Finally, you can decide how to save or view the results. Nmap supports multiple output formats, including standard output, XML, and even a greppable format for advanced processing. The last is a target IP. This is one of the most critical and mandatory piece of information. Without a target, Nmap does not know where to look. The target can be a single IP, a range of IPs, or even a host name. By understanding these elements, you'll have a complete control over your scans, tailoring them to meet your exact needs. Before getting into Nmap IP scanning, let's quickly talk about the cheat sheets available for Nmap. These cheat sheets are the great source of saving time and help you run commands efficiently. If we open a browser and type Nmap cheat sheet, in the search bar, you'll find several options. Two popular ones are StationX Nmap cheat sheet and the other one is Compatibility Nmap cheat sheet. Talking about the StationX Nmap cheat sheet, this is my go-to cheat sheet because it's interactive. It allows you to search for specific commands and copy them directly, making it super easy to use. The other one we have is a Compatibility Nmap cheat sheet. This one is available in PDF format, which is handy for offline reference. It's well organized and provides a quick overview of commonly used commands. While both are useful, I prefer the StationX cheat sheet for its simplicity and ease of navigation. These resources make learning and using Nmap much easier, so keep them in mind as we proceed. Let's start with Nmap IP scanning first. Nmap gives you multiple ways to define your targets, making it a highly flexible tool for scanning networks. Let's break it down. First, let's start with single IP. So let's type the command. This is the simplest way to target a single device by specifying its IP address. This method is great for focused scans on a specific machine. There you go. Here we have the results. Now let's see the subnet range. Here we specify an entire subnet using CIDR notation. This is ideal for scanning all devices in a network range, such as a small office network. Next, let's search for an IP range. Let's type the command for it. If you need to scan a specific range of IPs, you can use a hyphen to define the range. This is useful when you know the range of active devices you want to scan. Next, let's search for the specific IPs. Sometimes you might want to scan multiple non-sequential IPs. You can list them directly, separated by spaces. Next, let's try searching with a text file. For this, we'll open our editor. So we'll enter some random IP that we want to search. Now let's save this on the desktop with the name targets.txt. Now we'll minimize this. Now let's go to our desktop directory on our terminal. Now let's enter the command. For larger or predefined target lists, you can save the IPs in a text file and use the IL flag to load them. This method is perfect for batch scanning without manually entering IPs. Next, let's search for a domain. Instead of using IP addresses, you can directly scan a domain name. Nmap will resolve the domain to its corresponding IP address and scan it. This is especially useful for web servers and hosted services. So we have the results here for edureka.𝐶. Next, let's learn Nmap port scanning. Now that we have covered how to specify targets, let's talk about ports. Ports are crucial in understanding the services running on a host, and Nmap offers several ways to scan them based on your needs. Let's break them down with examples. First, let's start with the single port scanning. Let's type the command for it. If you're interested in a specific port, like port 80 for HTTP services, you can use the P flag, followed by port number. This is perfect for focus scans. Next, let's search for the sequential ports. This scans a range of ports sequentially, like ports 20 through 25. It's useful when you want to check multiple consecutive ports. Next, let's search for the distributed ports only. You can also scan non-sequential ports by listing them with commas. This allows you to focus on ports of interest, such as SSH, HTTP, and HTTPS. Next, let's find the specific services. Let's type the command for it. Sometimes you might want to target a specific service running on a port. Using scripts like HTTP title with the P flag focuses on identifying specific service details, such as web servers. Next, let's search for the protocol-specific ports. Nmap allows you to scan ports for specific protocols. For instance, scanning port 53 with SU flags targets UDP traffic, which is commonly used for DNS servers. Next, let's search for all the ports. If you're unsure about which port are in use, you can scan all 65,535 ports with -P flag. This provides a comprehensive view of host open ports. So if you hit enter, it will show us the status of the scan. So here you can see that the status is 39.66%. And the estimated time for the completion of the scan is 13:15. That is 1:15 p.m. We'll cancel this and move on to the next scan. Now we will scan for the top 100 ports. To save time, you can scan the most commonly used ports using the top ports option. For example, scanning the top 100 ports gives a quick snapshot of the most relevant ones. Now that we have covered how to specify targets and scan ports, let's dive into the different scan types Nmap offers. Each scan type serves a specific purpose, allowing you to choose the most appropriate method depending on your goals. Let's go through each of them. First, we will begin with a simple ping scan. Let's type the command. A ping scan is the simplest form of scanning, used to determine if a host is up or down. It doesn't scan ports but sends ICMP echo requests to see if the target responds. Next, let's move on to the SYN scan, better known as the stealth scan. The SYN scan is the most popular and stealthy scan. It sends a SYN packet to a target port and waits for a response. If the port is open, it replies with a SYN ARC. The scan doesn't complete the TCP handshake, making it stealthier and harder to detect. Next, let's talk about the TCP Connect scan. The TCP Connect scan is a more straightforward approach. It completes a TCP handshake by sending a SYN, receiving a SYN ACK, and then sending an ACK. While it's easier to detect, it's useful when a SYN scan is blocked or unavailable. Next, let's search for the UDP scan. Unlike TCP, UDP doesn't have a handshake, making it more challenging to scan. The UDP scan sends a datagram to the target port and waits for a response. If there is no response, the port is open or filtered. Next, let's do a FIN scan. A FIN scan sends a FIN packet to the target port, which typically indicates that the sender has finished communicating. This scan can be useful to bypass certain firewalls and packet filters because it doesn't behave like a typical connection request. Next, let's search for the null scan. A null scan sends a packet with no flag set, essentially making it appear like an empty packet. This can sometimes bypass firewalls that only look for established connections but may be more likely to get blocked by modern firewalls. Next, let's perform an XMS scan. The XMS scan sends a packet with the FIN, PHS and also an URG flag sets. It's called the XMS scan because the flags are set like lights on a Christmas tree. It's another stealthy scan type that can bypass certain types of filtering systems. Next, let's perform an ACK scan. An ACK scan is primarily used to map out firewall rule sets rather than identifying open ports. It sends ACK packets to the target ports and analyzes the responses to determine if the ports are filtered or not. Next, let's perform a window scan. Let's type the command for it. The window scan is similar to an ACK scan but uses the TCP window size to determine the state of the ports. It's useful for mapping firewall rules and bypassing certain filtering systems. Next, let's perform an idle scan. The idle scan is one of the stealthiest scans. It uses third-party device to send packets to the target, making it difficult to trace the scan back to the attacker. This type of scan is often used to avoid detection. Next, let's perform the remote procedure call scan. The RPC scan is specifically designed to identify services that use the remote procedure call protocol. This is useful for scanning systems running services like NFS or SMB. Next, let's perform an OS detection scan. By using the O flag, Nmap tries to identify the operating system and OS version of the target host. This scan relies on TCP IP stack fingerprinting to determine the OS based on how the target responds to various network probes. Lastly, let's do a version detection scan. A version detection scan identifies the version of the services running and open ports. This is useful for discovering vulnerabilities specific to certain software versions. Next, let's talk about scan timing in Nmap. When you run a scan, the speed and intensity of the scan can be adjusted using different timing options. Nmap offers a range of timing from T0 to T5 to help you balance speed, stealth, and accuracy. Let's break down each one. First, let's start with the T0, that is also known as a paranoid scan. Let's type the command for it. T0 is the slowest timing option and is used for extremely stealthy scans. It's designed to minimize detection by firewalls and intrusion detection systems by making the scan extremely slow. This option is great for situations where you need to be as discreet as possible, but it may take a long time to complete. Now, let's cancel this and move on to our next scan type, because this might take a longer time. The next scan we have is T1, that is also known as a sneaky scan. T1 is still slow but a bit faster than T0. It's often called a sneaky scan because it is designed to avoid detection while still being faster than a T0 scan. It's useful for reconnaissance when you need to remain hidden but don't have time for a T0 scan. Let's cancel this and move on to our next scan type. Let's see the T2 scan, that is also known as the polite scan. T2 is a polite scan. It's still slow but avoids overwhelming the target network or host with too many requests at once. This scan type is useful when you don't want to create too much traffic or disrupt the network. Similarly, we have another scan, that is a T3 scan. T3 is the default setting for Nmap and provides a good balance between speed and stealth. It's called a normal scan and it's the best option when you don't need to be overly stealthy or slow. It's a great option to most general use cases and should be used when speed and accuracy are more important than being undetected. Now let's move on to the T4 scan, that is the aggressive scan. T4 is an aggressive scan. It scans faster by sending more packets at once, which can lead to quicker results but also increase the chance of detection by firewalls and intrusion detection systems. This option is useful when you need quickly gather information and don't mind being noticed by the target machine. Lastly, let's move on to the T5 scan, which is the insane scan. T5 is the fastest and most aggressive scan. It's called an insane scan because it attempts to scan as quickly as possible, which makes it highly detectable. It sends a high volume of requests in a short time. So, while it may provide very fast results, it can also overwhelm the network and alert security systems. Use this only when you need fast results and when stealth is not a priority. Now, to summarize, here are the different timing options and their characteristics. First, we have the T0, which is very slow and stealthy. Then the T1, which is slow and sneaky. Next comes the T2, which is slow and polite. T3, which is normal and balanced as well. Then is the T4, which is fast and aggressive. The last is T5, which is very fast and insane. Now, let's take a look at the output types available in Nmap. Nmap offers several formats for saving the results of your scan, which can be useful for analysis, automation, and reporting. Let's go through each of them. First, we have is a normal text format output. Let's type the command for it. The normal text format is the default and simplest output format. It generates a human-readable report with basic information about the scan results such as open ports, services, and other details. This format is great for quick, easy-to-read reports and is the most common format used by most Nmap users. Next is the XML format output. The XML format is used when you need to process the scan results further and integrate them with other tools. It generates a structured XML file that contains all the details of the scan, including host information, open ports, and service details. This format is ideal for automation and scripting, especially when you want to parse the results with other programs. Next is the greppable format output. The greppable format is designed for easy searching and parsing using tools like grep. It outputs scan results in a simple, line-by-line text format that makes it easy to filter or search for specific data. Although it's not the most human-friendly, it's useful for quickly extracting certain details from large scan results. However, Nmap does not recommend this format for serious analysis, as it can sometimes omit important details and isn't as structured as other formats. The next is the script kiddie format output. The script kiddie format is a very basic format designed primarily for people who aren't familiar with Nmap's detailed output. It gives minimal information in a simple format, and while it's not commonly used by experienced users, it may be useful for beginners or for quick checks. However, it's not recommended for professional or detailed analysis due to its lack of depth. Finally, let's talk about the Nmap script engine. NSE is a powerful feature of Nmap that allows you to extend its functionality with custom scripts. These scripts are written in Lua and can automate a variety of tasks, helping with network discovery and security auditing. NSE scripts can be used for a range of purposes, such as firewall bypass, which helps bypass firewalls, or IDS, IPS systems to avoid detection during scans. Next is the FTP enumeration. Gathers information about FTP servers including user accounts and shared directories. Then comes the DNS enumeration. Extracts DNS records and identifies potential misconfiguration in DNS servers. Last is the HTTP enumeration. Identifies web applications and hidden directories on HTTP servers, potentially exposing vulnerabilities. These scripts are located in the scripts directory of Nmap's installation. For example, on Parrot OS, you can find them at, type the command for it. As you can see, here we have all the scripts. The NSE scripts are incredibly useful for penetration testing and network analysis. They help automate complex tasks and provide deeper insights during security assessments. With this, we have come to an end to this video on Nmap tutorial. If you enjoyed listening to this video, please be kind enough to like it. And you can comment on any doubts and queries. We will reply to them at the earliest. Look up for more videos and playlists and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.